Welcome back. Thanks for joining us again. Bear with me on this one. This is going to be a long sub-element. Sub-element E9 covers antennas and transmission lines. 8 exam questions come from the 8 groups. E9A is basic antenna parameters. Radiation resistance, gain, beam width, efficiency, effective radiated power, and effective isotropic radiated power. Let's get started with E9A01. What is an isotropic radiator? C. A hypothetical lossless antenna having equal radiation intensity in all directions, used as a reference for antenna gain. E9A02 says, what is the effective radiated power of a repeater station with 150 watts transmitter power output, 2 dB feed line loss, 2.2 dB duplexer loss, and 7 dBd antenna gain? It is D, 286 watts. E9A03, what term describing the total radiated power takes into account all gains and losses? C, effective radiated power. E9A04, which of the following factors affect the feed point impedance of an antenna? B, antenna height. E9A05, what does the term ground gain mean? D, an increase in signal strength from ground reflections in the environment of the antenna. E9A06, what is the effective radiated power of a repeater station with 200 watts transmitter power output, 4 dB feed line loss, 3.2 dB duplexer loss, 0.8 dB circulator loss, and 10 dBd antenna gain? A, 317 watts. E9A07, what is the effective isotropic radiated power of a repeater station with 200 watts transmitter power output, 200 dB feed line loss, 2.8 dB duplexer loss, 1.2 dB circulator loss, and 7 dBi antenna gain? It's B, 252 watts. E9A08, what frequency band has the smallest first Fresnel zone? That's A, 5.8 gigahertz. E9A09, what is antenna efficiency? That's B, radiation resistance divided by total resistance. E9A10, which of the following improves the efficiency of a ground-mounted quarter-wave vertical antenna? A, installing a ground radial system. E9A11, which of the following determines ground losses for a ground-mounted vertical antenna operating on HF? C, soil connectivity. E9A12, how much gain does an antenna have compared to a half-wave length dipole if it has 6 dB gain over an isotropic radiator? A, 3.85 dB. E9B covers antenna patterns and design, azimuth and elevation patterns, gain as a function of pattern, and antenna modeling. E9B01, what is 3 dB beam width of the antenna radiation pattern shown in figure E9-1? It's B, 50 degrees. E9B02, what is the front to back ratio of an antenna radiation pattern shown in figure E9-1? And that's D, 18 dB. E9B03, what is the front to side ratio of the antenna radiation pattern shown in figure E9-1? D, 14 dB. E9B04, what is the front to back ratio of the radiation pattern shown in figure E9-2? B, 28 dB. E9B05, what type of antenna pattern is shown in figure E9-2? A, elevation. E9B06, what is the elevation angle of peak response in the antenna radiation pattern shown in figure E9-2? It's C, 7.5 degrees. E9B07, what is the difference in radiated power between a lossless antenna with gain and an isotropic radiator driven by the same power? C, they are the same. E9B08, what is the far field of an antenna? It's D, the region where the shape of the radiation pattern no longer varies with the distance. E9B09, what type of analysis is commonly used for modeling antennas? B. Method of moments. E9B10, what is the principle of a method of moments analysis? A. A wire is modeled as a series of segments, each having a uniform value of current. E9B11, what is the disadvantage of decreasing the number of wire segments in an antenna model below 10 segments per half wavelength? C. The computed feed point impedance may be incorrect. E9C, practical wire antennas, folded dipoles, phased arrays, effects of ground near antennas. E9C01, what type of radiation pattern is created by two quarter wavelength vertical antennas spaced half wavelength apart and fed 180 degrees out of phase? That's D, a figure 8 oriented along the axis of the array. E9C02, what type of radiation pattern is created by two quarter wavelength vertical antennas spaced quarter wavelength apart and fed 90 degrees out of phase? A. Cardioid. E9C03, what type of radiation pattern is created by two quarter wavelength vertical antennas spaced half wavelength apart and fed in phase? C. A figure 8 broadside to the axis of the array. E9C04, what happens to the radiation pattern of an unterminated long wire antenna as the wire length is increased? B. Additional lobes form with major lobes increasingly aligned with the axis of the antenna. E9C05, what is the purpose of feeding off an off-center fed dipole between the center and one end instead of at the midpoint? A. To create a similar feed point impedance on multiple bands. E9C06, what is the effect of adding a terminating resistor to a rhombic or long wire antenna? B. It changes the radiation pattern from bidirectional to unidirectional. E9C07, what is the approximate feed point impedance at the center of a two-wire half-wave folded dipole antenna? A. 300 ohms. E9C08, what is a folded dipole antenna? That's C. A half-wave dipole with an additional parallel wire connecting its two ends. E9C09, which of the following describes a G5 RV antenna? A. A wire antenna center-fed through the specific length of an open wire line connected to a balun and coaxial feed line. E9C10, which of the following describes a ZEP antenna? B. A end-fed half-wavelength dipole. E9C11, how is the far-field elevation pattern of a vertically polarized antenna affected by being mounted over seawater versus soil? D. Radiation at low angles increases. E9C12, which of the following describes an extended double ZEP antenna? C. A center-fed 1.25 wavelength dipole antenna. E9C13, how does the radiation pattern of a horizontally polarized antenna vary with increasing height above ground? B. The takeoff angle of the lowest elevation lobe decreases. E9C14, how does the radiation pattern of a horizontally polarized antenna mounted above a long slope compared to the same antenna mounted above flat ground? B. The main lobe takeoff angle decreases in the downhill direction. E9D, Yagi antennas, parabolic reflectors, feed point impedance and loading of electrically short antennas, antenna Q, and RF grounding. E9D01, how much does the gain of an ideal parabolic reflector antenna increase when the operating frequency is doubled? D. 6 dB. E9D02, how can two linearly polarized Yagi antennas be used to produce a circular polarization? C. Arrange two Yagis on the same axis perpendicular to each other with the driven elements at the same point on the boom and fed 90 degrees out of phase. E9D03, what is the most efficient location for a loading coil on an electrically short whip? A. Near the center of the vertical radiator. E9D04, why should an antenna loading coils have high ratio of reactance to resistance? C. To maximize efficiency. E9D05, approximately how long is a Yaggies driven element. It's half wavelength. E9D06, what happens to SWR bandwidth when one or more loading coils are used to resonate an electrically short antenna? B. It is decreased. E9D07, what is an advantage of top loading an electrically short HF antenna? D. Improves radiation efficiency. E9D08, what happens as the Q of an antenna increases? B. SWR bandwidth decreases. E9D09, what is the function of a loading coil in an electrically short antenna? D. To resonate the antenna by canceling the capacitive reactance. E9D10, how does the radiation resistance of a base-fed whip antenna change below its resonant frequency? B. Radiation resistance decreases. E9D11, why do two-element Yaggies with normal spacing have a reflector instead of a director? D. Higher gain. E9D12, what is the purpose of making a Yaggies parasitic elements longer, either longer or shorter than resonance? C. Control of phase shift. E9E covers impedance matching, matching antennas to feed lines, phasing lines, power dividers. E9E01, which matching system for Yaggy antennas requires the driven element to be insulated from the boom? B. Beta or hairpin. E9E02, what antenna matching system matches coaxial cable to an antenna by connecting the shield to the center of the antenna and the conductor of a fraction of a wavelength to one side? That's A. Gamma match. E9E03, what matching system uses a short length of transmission line connected in parallel with the feed line at or near the feed point? That's D. Stub match. E9E04, what is the purpose of series capacitor in a gamma match? B. To cancel unwanted inductive reactance. E9E05, what Yaggy driven element feed point impedance is required to use a beta or hairpin matching system? A. Capacitive driven element electrically shortened than 1/4 or 1/2 wavelength. E9E06, which of these transmission line impedances would be suitable for constructing a quarter wavelength Q section for matching a 100 ohm feed point impedance to a 50 ohm transmission line? C. 75 ohms. E9E07, what parameter describes the interaction of a load and transmission line? It's B. Reflection coefficient. E9E08, what is the use for Wilkinson divider? C. To divide power equally between two 50 ohm loads while maintaining 50 ohm input impedance. E9E09, which of the following is used to shunt feed a grounded tower at its base? That's C. Gamma match. E9E10, which matching system places an inductance across the feed point to a vertical monopole antenna? C. Beta or hairpin. E9E11, what is the purpose of using multiple driven elements connected through phase lines? A. To control the antenna's radiation pattern. E9F, transmission lines, characteristics of open and shorted feed lines, coax versus open wire, velocity factor, electrical length, coaxial cable dielectrics, and microstrip. E9F01, what is the velocity factor of a transmission line? D. The velocity of a wave in the transmission line divided by the velocity of light in a vacuum. E9F02, which of the following has the biggest effect of velocity factor of a transmission line? C. The insulating dielectric material. E9F03, what is the electrical length of a coax cable longer than its physical length? Why is an electrical length of a coaxial cable longer than its physical length? Because D. Electromagnetic waves move more slowly in a coaxial cable than in air. E9F04, what impedance does a quarter or half wavelength transmission line present to an RF generator when the line is shortened at the far end? B. Very low impedance. E9F05, what is microstrip? And that's D. Precision printed circuit conductors above a ground plane that provide a constant impedance interconnects at microwave frequencies. E9F06, what is the approximate physical length of an air-insulated parallel conductor transmission line that is electrically half wavelength long at 14.10 megahertz. Answer is 10.6 meters. Answer C. E9F07, how does parallel conductor transmission line compare to coaxial cable with a plastic dielectric? A. Lower loss. E9F08, which of the following is a significant difference between foam dielectric coaxial cable and solid dielectric coaxial cable, assuming all other parameters are the same? D. All of these sources are correct. So, foam dielectric coaxial cable has lower safe maximum operating voltage. Foam dielectric coaxial cable has lower loss per unit of length. Foam dielectric coaxial cable has higher velocity factor. E9F09, what impedance does a quarter wavelength transmission line present to an RF generator when the line is shorted at the far end? A. Very high impedance. E9F10, what impedance does a 1/8 wavelength transmission line present to an RF generator when the line is shorted at the far end? That's C. An inductive reactance. E9F11, what impedance does a 1/8 wavelength transmission line present to an RF generator when the line is open at the far end? C. A capacitive reactance. E9F12, what impedance does a quarter wavelength transmission line present to an RF generator when the line is open at the far end? D. A very low impedance. E9G covers the Smith chart. E9G01, which of the following can be calculated using a Smith chart? A. Impedance along transmission lines. E9G02, what type of coordinate system is used in a Smith chart? B. Resistive circles and reactance arcs. E9G03, which of the following is often determined using a Smith chart? C. Impedance and SWR values in transmission lines. E9G04, what are two families of circles and arcs that make up the Smith chart? That's C. Resistance and reactance. E9G05, which of the following is a common use for a Smith chart? A. Determine the length and position of an impedance matching stub. E9G06, on the Smith chart shown in figure E9-3, what is the name of the large outer circle on which the reactance arcs terminate? That's B. Reactance axis. E9G07, on the Smith chart shown in figure E9-3, what is the only straight line shown? That's B or D, the resistance axis. E9G08, how is a Smith chart normalized? C. Reassign the prime center's impedance values. E9G09, what third family of circles is often added to a Smith chart during the process of designing impedance matching networks? A. Constant SWR circles. E9G10, what do the arcs on the Smith chart represent? D. Points with constant reactance. E9G11, in what units are the wavelength scales on a Smith chart calibrated? B. In fractions of transmission line electrical wavelength. E9H, receiving antennas. Radio direction finding techniques, beverage antennas, single and multi-turn loops. E9H01 says, when constructing a beverage antenna, which of the following factors should be included in the design to achieve good performance at the desired frequency? D. It should be at least one wavelength long. E9H02, which is generally true for 160 and 80 meter receiving antennas? A. Atmospheric noise is so high that directivity is much more important than losses. E9H03, what is receiving directivity factor? D. Peak antenna gain compared to average gain over the hemisphere around and above the antenna. E9H04, what is the purpose of placing an electrostatic shield around a small loop direction finding antenna? B. It eliminates unbalanced capacitive coupling to the antenna surroundings, improving the depth of its nulls. E9H05, what challenge is presented by a small wire loop antenna for directional finding? A. It has bidirectional null pattern. E9H06, what indicates the correct value of terminating resistance for a beverage antenna? D. Minimum variation in SWR over the desired frequency range. E9H07, what is the function of a beverage antenna's termination resistor? B. Absorb signals from the reverse direction. E9H08, what is the function of a sense antenna? A. It modifies the pattern of a DF antenna to provide a null in only one direction. E9H09, what type of radiation pattern is created by a single turn terminated loop such as a pennant antenna? That's a cardioid. E9H10, how can the output voltage of a multi-turn receiving antenna, multi-turn receiving loop antenna be increased? That's by increasing the number of turns and or the area enclosed by the loop. Answer C. E9H11, what feature of a cardioid pattern antenna makes it useful for directional finding antennas? B. A single null. And that covers subelement E9. Thank you for joining us. I'm sorry it was so long. Hopefully you'll join us for subelement E0, which is much shorter. Thank you.